For this lesson, we're going to relate the factors of a polynomial to its graph. So our objective is to be able to use factors to sketch a graph. So let's take a look at some of the information we have for this first problem. And we're going to relate these factors to the polynomial. So I've already factored it here. So we want to look at this and just go over some of the information we already know. For instance, the degree of this is the largest exponent, so that's a 3. The leading coefficient is a 1. So what we know is, since this is an odd function, it's going to start either up or down, and the opposite end behavior will be in the opposite direction. Now, since the leading coefficient is positive, it's going to start down and end up as the end behavior. So the end behavior for this, we know, is going to be as x goes to negative infinity. Okay, as x goes to negative infinity, y is going to go to negative infinity. And as x goes to positive infinity, that y is going to go also to positive infinity. So starts down, ends up. Now let's take a look at these factors and just see how that influences this graph. Let's take a look at the graph itself. I'm going to take a look at the graphing calculator version of this graph. So putting this into this to the graphing calculator, the graph, if I look at it, it ends up looking like this third degree graph. Notice it goes through at -2, it goes through at 2, and it goes through at 4. Notice how that looks like information related to these factors. Each of these, the root of it, if you set it equal to 0, are those numbers. If I set this equal to 0, I get x equal to 4. If I set this equal to 0, I get x equal to 2. And if this is equal to 0, I get x equals -2. And that's exactly where this passes through the x-axis. Those are my x-intercepts. So if I'm sketching this graph, let's go ahead and draw a sketch here. So what I know is it's going to go through at the points -2, at 2, and at 4. Now, since we know the behavior of this graph is that it's going to start down and end up, I can start the graph down here, pass through here, go like this, pass through here, and come up like that to get a sketch of the graph based on the x-intercepts, which are based on the factors. Now, there's a few more details we want to talk about, but notice the comparison of these two. Now, as a sketch, I didn't worry about how high up it goes. It goes up pretty high because of this. As a sketch, I'm interested in where it crosses the axis and kind of the relative heights of the top and the bottom. All right, so let's go ahead and see if we can continue that idea down here with another one. So we're going to talk about sketching this graph, and if we think through what we just talked about, okay, first of all, on this one, the degree is still equal to 3. The leading coefficient is -1 at the beginning, so this one will start up and end down, and so the end behavior for this will be as x goes to negative infinity, y is going to go to positive infinity because it's going to start up, and as x goes to positive infinity, my y is going to go down, so it's going to go to negative infinity. Now let's take a look at what that graph looks like. Look at these factors and how this is worked out. Notice on this one, I've got 2 factors of x minus 2. Another way to write this would be, I could have -1 times x minus 4 times x minus 2, the quantity squared. Now because of that, when I look at the graph, you're going to see something different happen at this value. Remember, I'm looking for the intercepts. Intercepts are going to be at x equals 4 and x equals 2. Those are my 2 intercepts. Now let's go ahead and look at what our graph looks like. So as I pull up my graph, go ahead and turn this graph off, and then turn this graph on. All right, I'm gonna have to change my window here. Okay, so this one's gonna go down a little bit further. So as I take a look at the graph, notice when I graph it, this one's gonna, actually what I wanna do is zoom in a little bit. What's happening here? So it starts up, ends down, but what is happening in this region around 2 and 4? So I'm gonna zoom in a little bit on my Y values. So my window here, I'll change my Y min, maybe I'll leave it at -10, but my Y max, I'll change back to say a 5, so maybe I can see what goes on. So as I look at this graph, notice it comes down and it hits 2 and it bounces off the graph. Then it goes back up and it comes back down through the other axis. So it does have just 2 intercepts, but because out here at 2, okay, it's gonna come down and it's gonna bounce off the axis here, then go slightly up and then come back down through 4. So my end behavior does start up and down, but it bounces here. That's gonna be a key idea when you have 2 of the same factors, or even any even number of that. All right, so that's what we're gonna talk about, is this is what's called multiplicity. We wanna talk about what happens with our graphs with different factors. My multiplicity, what multiplicity means is that how many times we have a factor. Okay, so multiplicity how many factors. So up here before, what we had was, on this one, we had 2 factors of x minus 2. We had 1 factor of x minus 4. What happened up here is we had 1 factor of x minus 4, 1 factor of x minus 2, 1 factor of x plus 2. The pattern we see is when there's 1 factor, it just goes straight through it. If there's 2 factors, it bounces off of it. We can generalize that for odds and evens. So what we want to set up here is when it's an odd, it goes through the axis. When it's even, it bounces off the axis. It's not a technical term, but it's a graphic one, that idea of it bouncing off the axis. So here's what it will look like if we have a degree of 1, so just 1 factor, it's going to go straight through the axis at whatever that factor gives us as a root. When it's, this is a degree equal to 1, if our degree is higher, let's say it's the degree is equal to 3 or 5 or 7, what happens is as we get close to where that root is, it's going to slow down, come into the root, and then it's going to cross. It's still going to cross the axis, but then it's going to go through the axis onto the other side. So a degree of 3, 5, or 7, you get this curve to go in and out of that point with an odd multiplicity. Now with even multiplicity, when you get to that number, it's going to go ahead and just bounce off the axis there. So we're going to see that the graph itself will hit the axis. There's an intercept there, but it will then bounce off instead. So let's look at what this sketch could be. We're going to talk about what the sketch is based on, this multiplicity of it. I've got here a multiplicity of 1 for this. I've got a multiplicity of 2 for this, and a multiplicity of 3 for this one. Now, remember we're looking for the intercepts. So what would this be equal to 0? It would give me -1 for this one. What would this one be? It would give me x equals 1. And then what would this one be? It would give me x equals 3. Now, this is, let's talk about this, and I'll put this here. So when there's not an exponent listed there, remember it's implied to be a 1. So I have a total multiplicity of this, or total degree of this polynomial, if I were to multiply it out and do the entire multiplication, I have a 1 plus 2 plus 3 would give me a total degree here of equal to 6. Why that's important is that tells me it's an even graph, so either both sides are going to go up or both sides go down. Now, how you know whether both go up or down is the leading coefficient. Well, we don't have a negative out here. Remember out here, this one had a leading coefficient of -1, which factored out here. So when you have a negative out in front of the whole thing, that means it's going to have a negative leading coefficient. On this one, because I don't have a negative there, my leading coefficient would be positive. I don't know what it is. Actually, I could figure that out. It's going to be equal to 1, a positive 1. But for now, all you have to know is that the leading coefficient is positive from looking at the factorization of it. There's no negatives in it. So it's going to start up and end up as well. Well, let's look at these numbers here. It's going to go through -1. It's going to go through 1, and it's going to go through 3. Now, what it's going to do at 1 is it's going to, remember, they're both starts up and ends up. So it's going to start up and come down through -1. Then it's going to come over to 1 here, and notice that's a 2. So it's going to bounce off of that factor. So that intercept it'll bounce off of because it's even, and then it's going to come back to the 3. That's an odd, and so what it will do is it'll have this effect of kind of curving into it and then curving out of it. So you kind of make it curve in and then you curve out of it to get your final end behavior going up there as well. So what we want is let's take a look at the graphing calculator now. On the graphing calculator, this one does go down quite a ways, so I'm gonna go ahead and open up my Y values here. Let's turn on this one to see what the actual graph looks like. So I'm gonna turn on this third one. Okay, the actual graph goes down quite a ways, so I'm gonna change my window here and go for a minimum, maybe down to -50. Now take a look at the graph. We're hoping it looks kind of like this for a sketch. Let's take a look. Okay, so it comes down, goes way down, and then it comes up, bounces at 1 here, and then goes up through 3. Now the part of the sketch that I didn't get is how far down it goes here. Okay, so we can use our graphing calculator to help to inform that. What we see on this one is that this graph down here goes down quite a ways. So I'll just modify my graph to go way down here in relationship to that one. And then it bounces off there and then curves in and curves out. So the idea that you need to get from this lesson is that the factors influence the intercepts, where if you set these equal to 0, you get where the intercepts are on the graph. And then the multiplicity, either odd or even, tells you the direction it goes through on this one. If it's an odd number, it's going to go through that intercept. If it's equal to 1, it goes kind of basically straight through, just like a line would. If it's even, it's going to bounce off the axis at that point. And if it's odd, larger than 1, like 3, 5, or 7, it's going to curve in and then curve out. That will help us use these factors to draw sketches of the graph.